with the change of state. Then again, when a liquid is heated at a particular temperature, the conversion from liquid state to gaseous state takes place. And as long as the change takes place, temperature remains constant. But we have to supply heat for the change. On the other hand, when heat is withdrawn, that is on cooling, gas changes to liquid, reverse process takes place. The reverse process also takes place at the same temperature. That means boiling point of a liquid will be same as the condensation point of the gas at constant pressure. Sometimes on heating a solid may directly change into vapor or gas. We call the process as sublimation. Iodine, ammonium chloride, camphor are some substances which sublime. Naphthalene balls we use. Their size keeps on decreasing without supplying any external heat, means by absorbing heat from the surrounding itself. So changing into vapor. We use naphthalene balls while keeping woolen clothes and all, so that insects are not there. So the process is sublimation. Now just reverse of the process also may take place, that is on cooling down. A gas directly changes to, or a vapor directly changes to solid. The process is called solidification. Okay, so these are the processes, names you should know, and the definition also, you studied it from the lower class itself. Now, we said during the process of change of state, there is no change in temperature. There is no change in temperature. For example, if we take one of the most common substances, that is ice, take some ice pellets in a beaker, a boiling test tube. Insert a thermometer into ice pellets. See that the thermometer does not touch on the walls of the container. Then keep on observing. You keep on observing what happens to the thermometer reading. You will see the thermometer reading showing 0 degree Celsius. And you can observe that ice keeps on melting. As long as the process of melting of ice takes place, even though you keep on heating, you may heat it on a burner, you may heat it in a water bath, no matter how much heat you supply, the temperature remains as 0 degree Celsius itself. And if you plot a curve over there, the curve will have the shape almost in this way. That is, you take time on x-axis and temperature on y-axis. Let us start from 0, 10 degree Celsius, temperature in degree Celsius. Temperature in degree Celsius. 20, 30, etc. whatever it is. And over here, time you may take in seconds. 5, 10, 15, 20, 30, let it be in minutes. Now, as long as the process of melting takes place, you will see the thermometer reading remains here. At 0 degrees Celsius itself. And once all ice melts, then the temperature keeps on increasing. When all of ice melts, then the temperature keeps on increasing. So it clearly shows that during the process of change of state, the heat energy given does not cause any increase in temperature. What is temperature? Temperature is the measurement of average kinetic energy of the molecules. Temperature is the measurement of average kinetic energy of the molecules of the substance. If there is no increase in temperature, that means average kinetic energy of the substance does not increase. But when we go to the total energy of the body, total energy or internal energy of a body is the energy due to motion of the molecules, which we call kinetic energy, along with energy due to the force of attraction, as well as energy due to molecular separation, energy which we call potential energy. So total energy is the sum total of kinetic energy and potential energy. Even though we supply energy, kinetic energy does not increase. That means which energy increases? Potential energy increases. And this increase in potential energy does not cause a change in temperature, so that is not visible. That is not visible there, and we cannot see that change in temperature. And this heat we call latent heat. So latent heat is the hidden heat over there, because the impact of that heat in the form of rise of temperature cannot be seen. That is why this heat is called latent heat. So latent heat of fusion. Latent heat of fusion of a substance is the amount of heat energy given to the substance at its melting point to completely convert it into liquid without any change in temperature. So latent heat of a substance, whole body. If we have x kilogram mass, say x kilogram ice at 0 degrees Celsius, then when we supply some heat energy, x kilogram ice at 0 degrees Celsius completely changes to x kilogram water at 0 degrees Celsius. Then the heat energy given That is the latent heat of ice over there. And when this latent heat is specially mentioned for unit mass of the substance. So two terms are there, latent heat and specific latent heat. Latent heat of fusion and specific latent heat of fusion. Specific latent heat is the heat required to convert the whole substance at its melting point to liquid without any change in temperature. That one is called latent heat. So naturally its unit is joule. But on the other hand, specific latent heat of a substance is the amount of heat energy required to convert unit mass of a given solid at its melting point into liquid completely without any change in temperature. Okay, so over here specific latent heat of fusion unit becomes joule per kilogram. So other units are also there where we use joule. Instead of joule we can use calorie, we can use kilocalorie, we can use kilojoule, no problem. And over here joule per kilogram, calorie per gram, kilocalorie per kilogram, joule per gram, all units can be used provided with you should know the conversion. That is 1 calorie is equal to 4.2 joules. Or if it is specifically given 4.18 joule, that also you will have to use. So let us stop here. In the next class we will continue with some more parts related to the specific latent heat and other things. Okay, thank you.